Welcome once again on the information technology series. We discussed about objects, patterns, classes, certain basic rules for managing the variables, as you would call in the algorithms, which are nothing but mathematical induction, degrees of freedom, and so on. See, when you have a variable stored in an object, the object has to be identified, right? Or the variable has to be identified. The variable value can be, as in the array, but every value represents something on the basic property of the array itself. For example, or the one which is containing that. Like, for example, my name is so and so, which means that I have something like maybe a property, maybe just a representation of something, maybe a god's name, maybe some nature's name, something it reflects, right? So whether I am like that or not is a different question altogether, of course, but there is a mapping, right? This is what means, this is what it is. So we are going to talk about the identities, how to identify something. Before we get on to the identity per se, in software parlance, there are 2-3 stages, I would call that way, where you see the object. If you are a programmer, probably you will write a code for a class. Sorry about that. So that means you are able to identify the object at the time of coding or programming. If you are using any modeling application, like where you can orchestrate how the screen should be, like you can design a page with a set of tools where you can drag and drop certain controls, followed by you can define the property for the controls and what values it can take. It's called RAD, Rapid Application Development. Softwares are available, which if you try, what will happen is that you can quickly design the screen, and maybe you will be in a position to transact also. But from that perspective, you have to design at the time of orchestration, or if you are writing a code, it's a time of designing. And when you are actually running it, that means when the code is getting executed, at the time of execution, when the program is running, that is the runtime. So these 3 times are there. I just repeat, this is the configuration time or orchestration time, design time, and the third one is runtime. Okay. So how do you identify in the first 2 is absolutely the developer's problem. But at runtime, if the behavior is different, then it is going to cause some problem for your users. So from that perspective, you need to identify at the time of either configuration or orchestration, or at the time of coding, programming. You must have that kind of intelligence to know that how this class or object is going to behave at runtime, because there are other dimensions, like the underlying framework, the underlying operating system, some external inputs. All those things will come and hit on that program at runtime. So you need to know. Otherwise, what will happen is that you will do FI and do debugging for every line of code. Okay, thank God there is no wear and tear on the code. Otherwise, for every time when you run a code, suppose one word is off, then imagine your tire on your vehicle. If something goes off, programmers will go crazy, right? So thank God that is not the way computing has been designed. So you can be a little safe. But what you have to be, you have to remember is that at runtime you need to know how all your classes and objects and functions are going to behave. Whatever may be the behavior or the expected functionality of that, you must have that sense first, then only you can impart that sense to the code so that it behaves at runtime. That's how the step flows. So in order for you to know how you whatever you are going to write will behave at runtime, which that also you may not have a clue at this point in time, and while writing also you may not have much of the clue, but at least you will know something. Then the only input to the whole situation is you, the developer. So the idea is to impart that knowledge to you at this point in time. So there are three identities which you have to remember. The one is the object identity, which is the class and the object, and what are the variables thereof, and what are the functions thereof, and how these variables and are going to be interpreted or updated during the program runs. Then you have a location. Location need not be your GPS kind of a location. Location can be in the flow where the class gets instantiated. For example, there are two entry points to the class, and one guy calls the class and instantiates object 1. The other guy calls the object from the second place and instantiates as object 2. And these two are two different objects for two different purposes, but need not share the data between these two objects. If that is the case, whereas you have a common variable, then whatever is the last value of the variable will be used, set by one program will be, or one object will be used by the other object. So you need to remember which will be a class variable, or which will be a object variable, or a temporary variable you use. So and particularly when there are two or multiple ways of instantiating that particular class, that you have to remember very carefully. So the location here in the context of how the flow goes, or who is instantiating, who the calling application is, who the caller is. Okay, so maybe if you may think that the caller is calling once, but the caller himself or him, meaning here the object or the class, I'm just using the gender him or he here just to reflect. So if that the calling application itself is going to be called by another calling application, and that has got multiple instances, then your program will also have multiple instances because it is called. Or in another scenario, you have a base class, you have a derived class, and you have a derived class, and so on and so forth. You have a third level or fourth level of derived class, and at the same time, and when somewhere in the hierarchy, you are also extending from some other class. Okay, and you create an object. So imagine the complexities there. So that particular code, when if it is instantiated from some other instance, and from in this from the base class, if it gets instantiated, then how the objects will interact with the data. So the location here is the parent identification, or the parent class or object identification. You can call very simply like parent, but within the framework it won't be referred as the way you call the class as class. It will be some encoded or encrypted kind of object. Any framework will give you, so that even if you debug, you can go through only that way. You can debug in the code, but at runtime I'm saying runtime having a debug is difficult. So you need to remember that how to identify that object. So at any point in time, any line of code or function or the variable, you can't say the line of code has got a meaning, but a set of lines of code in a block of a function or the whole function itself has got a meaning. So from that perspective, you need to design your class, design your variable, naming convention of the variable in such a way that you can identify at runtime if there are any issues. The third dimension to that is time, because when two classes are going to, when two different calling applications are going to be instantiating the same object, it need not be at that second of the thing. It can be there can be a difference in terms of millisecond or microsecond between these two objects. So but when it comes to persistence of a record, that record has to be saved in a database or in a file, for example. Then it needs to have a timestamp or a datetime property, associated with that record. So you need to have that element also into your application design or the class design or the object design. So I just repeat for the for a quick recap on this. One is the object identification, second is the location identification, third is the time identification. With these three you can do that. There are another dimension to the identification technique, like there are certain data. For example, you are applying for a account in a bank. So the customer would ask you what is your first name, what is your last name, what is your date of birth, email ID, etc. So all these things are domain related data points or data variables or data in general to represent that this is so and so customer. Once they have that, then what happens is that there is a business related data which need to be also appended to that, like for example a customer code which may be generated by the software itself on behalf of the bank, and maybe what is your account code, what is your customer code. These two related to the business data, and there could be other set of data which is called as administrative data, like who was created, which means that who is the user who has created a record for you in that system. So that is a administrative data which corresponds to the user ID of the user who was created, and the date on which it was created, and created by whom, or modified means modified by whom, on what modification date, and how many modifications it has gone through, and so on and so forth. So many data elements you can store as part of the administrative data. So so this is how you structure a class or object, and you also have a mechanism to run at runtime know that how this domain plus business plus administrative data is being loaded at runtime and against a time series, like when the object was created. People call the port time or some central server's time, maybe stored as UTC. So at any point in time, irrespective of your location, the data will get stored. So like that, the data should get stored so that it is. We discussed about traceability in one of the series. So you have to design the data in such a way that the traceability is there, so that tomorrow when there is a problem, right, either at runtime or at the coding time or at the orchestration, you can always find out which is the cause of the particular bug, or who is, or who meaning here the calling application is creating the problem, or the class itself is having a problem or not. So it is very easy for you to find out and debug accordingly. Okay, and once you have these things in mind, if you start doing this with this insight, what happens is that any new screens you have to develop, for example, you can structure all those things around these data points, and obviously there is a function to change the values of this data. I'm not talking about the function, I'm just talking about the variables here, or the data here at this point in time. So you can think about from that perspective and design a beautiful application on day one, and without anybody's help and without a bug. Okay, so with that insight, hope I come across to you, and make sense to you. And one important thing which I want you to try is that you assume, I'm assuming that you have written code in the past, and suppose there is a class A, and there are say 2-3 variables, and there is a function, say function 1 in class A. Okay, and you in class B, you just write some dummy code and try to instantiate, maybe you inherit that and then instantiate this function 1. Okay, just run it in a loop for 100 times, and how many times this class A function 1 is called. The other example which you can try is that you define class A like this, the same way class B function 2, class C function 3, like that you derive, and B is derived on A, and C is derived on B, and D is derived on C, and E is derived, like that. You try to do that, and see at the Z level, or X, Y, Z level, whatever is that level. Okay, so you try to have the class C and function 26, and see how that behaves. The underlying framework, whether it is .NET framework, or it's a Java framework, or any class framework, you can't trace it beyond that. And the length of the class, that also I want to tell you, don't say A, you create some 200 length class names. And the same way, the function 1, don't say function 1, let that length be another 200 character length. Like that you do for A to Z. Then imagine and you run it and see it for yourself, whether it works or it crashes, because the underlying the way you define the classes and the functions or any names thereof, that is not the way the underlying framework, whether it is Java or .NET or any JavaScript framework, will recognize that way. Any object-oriented, for example, object-oriented programming framework, they won't call that as class A and function 1. It's called mangled name. That's the actual sense. And the mangled name is like a encrypted name which you can't read it out. And every class, every instance of the class, and every functions you are trying to call will have a maligned name and mangled name, and at some point in time, depending upon your memory, it may crash or it may even work depending upon the space, and you can try to inspect that object and see it for yourself. That's a kind of small homework in case if you are interested. Otherwise, these are all the things, only under extreme conditions you will know what you have written is correct or not. Under normal condition, things will work. Okay, so when you are writing the code, have this insight of how to define these identities very clearly. Identities related to the class, object thereof, and the variables, and the naming convention for the functions. Hope you enjoyed this. Thank you. Cheers. See you in the next video. This is Gokul. Bye.